Okay, Assalamualaikum and good afternoon, everyone.
Waalaikumsalam, sir.
Okay, so today we will continue with our tutorial. So tutorial number 3. So last week we have learned about lecture 2B regarding the modeling the dynamics of translational mechanical system. So we will continue with the same topic, but we will discuss on tutorial number 3. Okay. So let's look at the question one by one. So question one, find the transfer function x2 over f of the following systems. Okay, so figure 1a, question A. So sorry for the poor figure quality. Okay, so figure 1a. So we have two boxes here which are connected by a spring and a damper, and a force is applied on block X1. Okay, so let's identify or let's find the transfer function by using the steps that we have learned last week. Okay, so there are 4 steps. So let's recap on the steps involved. So firstly, we need to identify input and output. Okay, so although the steps seems unnecessary, but it's better if you can follow the step given, so that when you answer, your answer is more complete. Okay. And then number 2, you draw the free body diagram. And then number 3 will be write the equation of motion. So equation of motion in frequency domain. And lastly, find the transfer function again. So transfer function TF. Okay, so let's look at how to answer question 1A. Okay, so we draw the free body diagram one by one. So we start with block number 1, block X1. Okay, so X1 is the direction is given moving forward, and we identify the elements that are connected to X1. So here we have a spring and a damper connected to X1. So the spring and damper will produce forces in such a way that it resists the motion of X1 moving forward. So the forces will be acting backward. So we have Okay, sorry, internet putus. Okay, okay, boleh nampak kan?
Boleh.
Okay, so we have 1 Newton second per meter for the damper. So we have the force 1 x1 dot. Okay, and don't forget the inertia because the box the box x1 has a mass m equals 1 kg. So we have another force backward equals 1 x1 double dot. Okay. Okay, so when you write the force, make sure you have the dots. Okay. Okay, sometimes when you write when you forgot to write the dot, so the examiner maybe deduct marks. Okay. Okay, so the dot represent velocity and double dot represent acceleration. So make sure you write it clearly. Okay. Okay, and then on the box we have a force, input force applied forward. So F. Okay, so I forgot step number 1 here. So should identify input and output first. Okay, but the question is already given you F as the input from the transfer function, F input, and X2 as the output. Okay, so you want to find X2 output and F as the input. Okay. Okay, back to the free body diagram, and we have input force F. And then from the spring and damper, we need to look at whether this spring and damper are connected with other mass bodies. Okay, so the spring and damper is also connected with body X2. So there are forces generated by X2, and the forces will be acting in the same direction of X1. Okay, so we have 1 x2 from spring and 1 x2 dot from the damper. Okay, so there is no friction given by the frictionless floor. So there is no effect of friction. So these are the forces for box X1. Okay, then we can draw the free body diagram for box X2. Okay, so the direction of X2 is forward as well. And on X2, we have spring and damper connected to X2. So there will be two forces acting backward, trying to resist the motion. Okay. So first we have 1 x2 from spring, and secondly 1 x2 dot from the damper. And also we need to consider the inertia because the box has mass. So we have 1 x2 double dot. And then the spring and damper also connected with x1. So there will be forces from x1 on x2. Okay. So first force is from spring, so 1 x1, and second one is from damper, 1 x1 dot. Okay, so there is no input force on x2. So here are the free body diagrams. Okay. So now you can write the equation of motion for both free body diagram. So from the first free body diagram, we have x1 double dot plus x1 dot plus x1 minus x2 dot plus x2 equals F. Okay, so force backward equals force forward. Okay, and you can write this in frequency. So it becomes S square plus s plus 1 x1 s. Okay, so I factorize and convert using Laplace transform. Okay, so if you are not sure, you can do it step by step, but here I skip steps. Okay, and then minus, or I put plus, minus s minus 1 x2 s, okay, equals f. So this is equation number 1. And then from the second free body diagram, so we have minus x1 dot plus x1 plus x2 double dot plus x2 dot plus x2 equals 0. So when I write the equation, I prefer to arrange them x1 first and then x2. But for your case, you can write in whatever you want, as long as you understand your answer. Okay. So I prefer to arrange x1 first and then followed by x2. Okay, because later it's easier for me to arrange them in matrix. Okay, then I convert this into frequency. So I got minus s minus 1 x1s plus x squared plus s plus 1 x2 s equals 0. Okay, so this is equation number 2. Now we can write the equation in matrix form. Okay, so I prefer to write them in matrix form because I can use Cramer's rule. Okay, but if you think you can do it by substitution, up to you. Okay, but I think the best method is by writing them in matrix. Okay, then I write them in matrix. So arrange the x1 first. So here I got s squared plus s plus 1 minus s minus 1, and then here minus s minus 1 and s squared plus s plus 1. Okay, the equation looks weird, but whatever. And then multiply x1 x2 equals f0. Okay, so the question wants you to find x2 over f. Okay, x2 over f. So meaning that you want to find x2. So to find x2, you can use Cramer's rule. So x2 equals, so the determinant of, so x2, basically you substitute the second column of the big matrix here, second column, by the input column here. So you get s squared plus s plus 1 minus s minus 1. So you substitute the second column by f and 0 and find the determinant, and divide it by the determinant of the original big matrix. So you get s squared plus s plus 1 minus s minus 1 minus s minus 1 s squared plus s plus 1. Okay, so usually the question may ask you to simplify the matrix. Okay, sometimes they ask you to leave it in determinant form, meaning you don't have to simplify the determinant. But here it's still x2, not x2 over f. So you need to at least simplify the top one, okay? Because here we have f here, so we need to bring this f on the other side, okay, on the left side. So we get x2 equals, so the top determinant you can simplify, you get f times s plus 1, okay, AD BC, okay, so AD minus BC, okay? So you need to go back to your matrix, okay, about matrix determinant. Okay. So AD minus BC, so you get F times S plus 1. And then the bottom one, you can get, or you can just write in bracket. You don't need to expand, okay? Okay. So here we have F. So you can bring this F over to the other side. So X2 over F equals this. Okay, so this is the final answer. Okay, sometimes you will have 3 by 3 matrix, which is more difficult to simplify the determinant. So sometimes the question will say leave it in determinant form. Okay. Okay, so this is the answer. Any question? Okay, so if you're okay, we move on to question B. Okay, in question B, figure 1B. So here now we have 3 boxes. Okay, so for 3 boxes, meaning that we have 3 degree of freedoms. So you have to expect there are 3 equations, 3 for free body diagram and 3 equation of motions. And the matrix will be in 3 by 3. Okay, so let's look at this question. So let's draw the free body diagram one by one. Okay, so the same input and output. So the input is F and output is X2. Okay, so meaning that we want the position X2 of the middle box. Okay, so let's draw the free body diagram. So let's start with free body diagram number 1. Okay, so on X1 we have a spring and damper connected to X1. So on X1 only one spring and one damper. Okay, there's nothing else connected, and even the floor is frictionless. So we have 2 forces that are trying to resist the motion X1. So we have 6X1 and we have 2X1 dot. And we have the mass. So we need to consider the mass, the inertia. So we have 4X1 double dot. And now let's look at the elements that are connected with other boxes. So here the spring is connected with the wall. So the wall is rigid, not moving. So meaning that the spring is not connected with other degree of freedom. And the damper here, the 2 Newton second per meter damper is connected with box X2. Okay, so we need to consider the forces from X2 on the damper, okay, by the damper. So we have a forward force, 2X2 dot. Okay, so there are no more components connected with other boxes. So this are only the forces on X1. Okay, let's look at second free body diagram. Okay, so on X2 we have one damper on top and one damper at the bottom and a spring. So there are 3 components connected with X2. So we have 3 forces trying to resist the motion. Okay, so first is 6X2 from spring, and then we have from one damper, top damper, and then the bottom damper, okay, to X2 dot. And then we have the inertia because of the mass. So we have 4x2 double dot. And then on the box x2, we have the input force F. Okay, so we need to consider the input force on x2. Okay. So the direction is forward. And now we look at the components on x2 that are connected with other bodies. So we have the damper connected with x1. So there will be a forward force to x1 dot. And the spring is also connected with x3. So we need to consider forces from x3. Okay, 6x3. And double check. I think these are all the forces.
So damper tu bukannya XT saya.
Sorry?
Yang untuk yang forward force tu bukannya 2x dot 3 untuk second punya free body diagram.
2x1 dot. Sebab 2 ni dia connected dengan x2 kan? Menjawab ke?
Ya, cuba memahamkan.
Okay, kita cari komponen yang connected dengan other bodies, dengan body selain x2. Contohnya damper ni dia connected dengan x2 dengan x1. Okay, so kita ada 2x2 dot and then 2x1 dot sebab dia connected dengan x1. Tapi spring ni dia connected dengan x2 dengan x3. So kita ada 6x2 dan 6x3. Okay, damper ni dia tak connected dengan x3. So dia connected dengan x1. Dan damper yang kat atas ni dia connected dengan dinding. So dinding tak bergerak. So tak ada degree of motion, tak ada forces from another degree of freedom. So only damper connected to x1 and the spring connected to x3. Faham kot, okay? Okay, let's look at the last box, x3. Okay, so x3 also direction is forward. So on x3 we have one spring connected to x3 and one damper connected to x3. So there are two forces resisting the motion. So 6x3 and 2x3 dot. And we have inertia because of the mass. So we have 4x3 double dot. And the spring is connected with x2. So we have a force forward, okay? So we have 6x2. And the damper is connected to wall. So there is no forward force from damper. So by checking, I think everything is okay. Now we can write the equation of motions for each of the free body diagram. So the first one we have 4x double dot 1 plus 2x1 dot plus 6x1 minus 2x2 dot equals 0. Okay, and then the second one we have minus 2x1 dot minus and then plus 4x2 double dot plus, so 4x2 dot because we have two dampers plus 6x2 minus 6x3 equals F. And then third free body diagram, so we have minus 6x2 plus 4x3 double dot plus 2x3 dot plus 6x3 equals 0. Okay, we write this in frequency domain using Laplace transform. So we have 4s squared plus 2s plus 6 x1. Okay, you can put s, but I don't have space, so kita buang perkataan s dulu. S kurungan x2 equals 0. And then second equation we have minus 2s x1 plus 4s squared plus 4s plus 6 x2 minus 6x3 equals f. And lastly, we have minus 6x2 plus 4s squared plus 2s plus 6x3 equals 0. Okay, you can write this in matrix form. Okay, serabut sikit. Okay, so you write this in matrix form. Okay, so let's look at x1 first. So we have 4s squared plus 2s plus 6 minus 2s 0, and then x2 minus 2s 4s squared plus 4s plus 6 and minus 6, and we have 0 minus minus 6. So we have 4s squared plus 2s plus 6 x1 x2 x3 equals 0f 0. Okay, so to make sure that your matrix is correct, I explained last week, your matrix must be in symmetric, okay, symmetric form. So here it's symmetric about this diagonal element, okay. So negative 2s equals negative 2s over here, 0 and 0, and negative 6, negative 6. Okay, so make sure it's symmetric. If it's not symmetric, then you maybe forgot some elements or whatever. So check again. And now the question wants x2 over f. So x2 meaning that you just replace the middle column with 0f0. Okay. So x2 equals, okay, because the matrix is big, so saya buat macam ni je, okay. 0f0. Okay. Yang faham je faham. Okay. Dalam exam jangan buat macam ni. Dalam exam tu lah macam cantik. Okay. Okay, so here it's still not simplified. So you can simplify the top matrix only. Okay, so let me show you how to simplify the top matrix. Okay. Kena tulis balik lah. So 4s squared plus 2s plus 6 minus 2s 0, 0f0, 0 minus 6, 4s squared plus 2s plus 6. Okay, ni benda lain. Okay. So to simplify this matrix, what you learned last time is guna top row ni, and then tutup ni, and darab silang, and then darab dengan elemen dekat yang kita tutup ni. Jadi kalau ingat balik lah, and then tutup ni, tutup yang second column pula, darab silang, dan seterusnya. Okay, so actually for determinant, you can choose any row or column that you want. sebagai tutup darat silang tadi. Okay. So in this example, it's better if you choose a row or column that has the most zero, ada banyak kosong. Okay, so for example, I choose okay, first row ni pun boleh dah, senang je sebenarnya first row ni. Or you can choose the second column here, second column, second row. Ada dua kosong dan satu F kat tengah. Okay, so let's choose the first row here, 4s squared plus 2s plus 6. Okay, so kita tutup row column ni darab silang. Okay, so AD minus BC, so we get F times 4s squared plus 2s plus 6. So the answer for the determinant, so disebabkan 2 ni kosong, tak payah kira lah. Okay, dia dah kosong, dia akan automatic dapat kosong. Okay, kalau tak faham, boleh tengok YouTube. Okay. So here we have 4s squared plus 2s plus 6 times F times this. Okay, plus 0 because this is 0. Darab silang, darab kosong akan dapat kosong, plus another 0 for the third column. Okay, darab silang and then darab 0. So you can simplify this. You can write F 4s squared plus 2s plus 6 squared. Okay. And then you can bring F over to the other side. So you can get x2 over F equals 4s squared plus 2s plus 6 squared over matrix determinant of the big matrix here. Okay, you can simplify this, but I think usually kalau 3 by 3 dia tak nak simplify pun. Okay. Okay, so you only need to simplify the top one. Usually the top one will have 2 0, ada 2 0 dekat F. So boleh simplify guna that column. Okay, kalau tak faham boleh Google. Okay, any question before we move on to question number 2? Okay, jangan malu-malu tanya. Okay? Tak faham, tanya je. Soalan macam bodoh pun tak apa. Saya cuba pandaikan. Okay, so let's look at question 2. So find the transfer function G of the following system. So the first one, GS equals x1 over f. Okay, so if you look at this system, x1 measures the movement of the block. Tapi pelik sikit kat sini, dia punya f ni not on the block. Selalunya f dekat block. But this time, the f is not on the block. It's in front of the spring. So when you find cases like this, when there's a force not connected on the block, but instead it's connected with in front of something else, so you need to create or add a degree of freedom, another degree of freedom on the F, okay, or in between the F and the things that it is connected. So in this case, you need to add a degree of freedom on FT. Okay, so you create another degree of freedom, maybe x2 here. So you can imagine actually the F, the force F is pulling a spring, this spring instead. Okay, F ni dia tarik spring tu, so spring tu akan ada degree of freedom dia sendiri, okay, which is independent of the degree of freedom of the box. Okay, so you need to add another degree of freedom x2 here. Then this system, even though only shows x1 or only have 1 degree of freedom in the figure, but this actually has 2 degree of freedom, okay, x1 and x2. Okay, so when you identify a new degree of freedom, then you can draw the free body diagram as usual. So let's start with x1. Okay, so on x1 we have a damper and spring connected with x1. So there will be two forces trying to resist the motion x1. Okay, we have the damper 5x1 dot, and from the spring 2x1. And don't forget the inertia of the mass. So we have 1x1 double dot. And then the spring is also connected with x2. So there is a force from x2. So here we have x2 to x2. And now consider for the second free body diagram, x2. So x2 is just a point without any mass. Okay, so we don't have a mass here. And on x2 we have a spring connected to x2. So we have one backward force trying to resist motion of x2. And then the spring is also connected with the box. So we have a forward force to x1. And then we have the input force F on x2. So we apply F. And no inertia because there is no mass on x2. Okay? So now you have the free body diagram. You can write the equation of motion and solve as usual. Okay? So for modeling the dynamics for translational mechanics and later on rotational mechanics, the most important part that you need to make sure it's correct is the free body diagram. So here you must make sure the free body diagram is complete with all the forces. Then you can write the equation of motion. Okay, so if this part is wrong, then insyaAllah semua jawapan sampai habis salah. Okay. So make sure this part is correct. Okay. Only this part is correct. So maybe from now onwards, I only show you a free body diagram. So to write the equation of motion and transfer function, you can do it by yourself. Okay. So here, make sure the free body diagram is correct and contains all the forces shown in the diagram or figure or questions. Okay, so let's look at example B. Okay, so in this example, so the question one x1, okay, sepatutnya x2 silap, okay, x2. But here x2 represent here something in between spring and damper. So it's actually similar to this above, the question A, where you actually measure the degree of freedom or the motion of a point, okay, a point in between two things. So here the point x2 is in between spring and damper and has no mass, okay. And here you need to introduce your own degree of freedom. So for example, the box 10 kg here. So the question doesn't give any degree of freedom, but it actually can move when there's a force applied, okay. So you need to introduce your own degree of freedom here. Okay, let's say x3, which represent the motion of the box. Okay, you need to introduce your own. And then the force here, F, is applied not directly on the box or on x2, but it's applied on the spring, okay, in front of spring. So in this case, similar to the above example A, you need to introduce another degree of freedom here. Maybe x1, okay. So now the system, you look initially has only one box which you can assume 1 degree of freedom, but now it actually has 3 degree of freedom. Okay. Okay, so let's draw the free body diagram for the system. Okay, so let's look at x1. So x1. So on x1 we have a spring to x1, and then the spring is connected with x2. So we have a forward force to x2, and then on x1 we have a forward force F input. So another F here forward. And x1 has no mass, so we don't have any inertia. Okay, so this is free body diagram x1. Let's look at x2. Okay, so on x2 we have spring and damper connected with x2. So we have spring to x2 and damper 5x2 dot. And then the spring is connected with x1. So there's a forward force on spring by x1. So 2x1. And then the damper is connected with the box x3. So you have a forward force from damper by x3. So we have 5x3 dot. There's no force or there's no inertia because there's no mass. Okay, so this is the free body diagram for x2. And lastly, the box. Okay, so on x3 we have a damper 5 Newton second per meter and another damper 2 Newton second per meter. So there are two dampers. So first one is 5x3 dot and second one is 2x3 dot. And then the first damper 5 Newton second per meter is connected with x2. So we have 5x2 dot. And then the second damper 2 Newton second per meter connected with the wall. So there is no forward force. And here x3 has mass. So you need to consider the inertia. So 10 x3 double dot. Okay, so you can check again whether you have all the forces on each free body diagram. Then you can write the equation of motion. Okay. So equation of motion tu boleh try tulis sendiri. Okay, as I said, the most important part is to get the correct free body diagram. Okay, any question? So, kalau soalan satu, A, B tu ada friction, direction, force, friction tu semua blok sama ke? Okay, if you have friction, like for example question 1, if you have friction, then you treat it as force yang try to resist motion. Okay, so let's say kita tengok figure 1A, this one. So let's say you have a friction here. Let's say dia lukis macam ni. Friction FV, for example FV1 here. And then FV2 here. So here you have additional force acting backward because dia akan resist motion X1. Okay, so X1 nak ke depan, tapi friction tu akan tolak dia kembali ke posisi asal. So we have FV1. So kalau friction, just multiply X1 dot, okay. And same for FV2. So you just add FV2 here. X2 dot. Macam tu je lah. Okay. Tak ada example tu dalam ni. So there's another example not shown in the tutorial. Sometimes you might get like ni lantai, and this is a box. Let's say box X1, let's say M1, and then you might have another box dekat atas dia, M2, and there's a friction in between these two boxes. Okay, let's say FV1, friction between two boxes. So when there's a friction between two boxes, you treat them as macam damper, macam ada connection like dampers. Okay. So for example, free body diagram, M1. So you have FV1 X1 dot. Okay. So X1 from friction effect on M1, but the friction also connected with X2. So you need to consider FV1 X2 dot. Okay. Ada effect dari X2. Okay, macam damper lah. Okay. Maybe you will see this kind of question dalam past years. Okay. Not sure in exam tak ada kot. Bosan soalan macam ni senang. Gila tiba. Okay, soalan macam ni dah pernah tanya. So tak tanya dah. Okay, maybe you will find this in past years. Okay. Later masa nak exam study week ke. Baru tergigit nak study past year. Weh, jumpa lah soalan ni apa ni. Gila tak belajar. Tu mula mencarut. Oh, lecturer tak ajar. Impact pun rendah, lecturer dapat. Bah tak ajar, padahal dah ajar dah. Okay, tadi fiction kalau tak faham tak apa, tanya lagi nanti. Okay, soalan friction tadi boleh dikaitkan dengan soalan 3. Soalan 3 ni dia ada friction, tetapi massless frame. Ada B2 kat sini, friction. Okay, so let's look at this figure. Okay, so this kind of figure actually very common in subject vibration. Okay. So later maybe for those who will take vibration next semester or already taken vibration this semester, you will find this kind of diagram. Okay. Ada massless platform box in a massless frame. Dia macam tak boleh nak terbayang benda ni. Okay, so let's look at how to draw the free body diagram of this figure, these structures. So a dynamic absorber is shown. This system is representative of many situations involving the vibration of machines containing unbalanced components. So the parameter M2, K2, B2 may be chosen so that the main mass M1 does not vibrate in response to foundation vibration. Okay, ayat yang last ni dia just beritahu je lah, tak penting pun. Okay. Dia beritahu yang kita boleh ubah M2, K2, B2 untuk dapat M1 punya mass vibration yang sesuai. Pointless lah ayat last ni. Okay. Sebab dulu ada student senior tanya, soalan kedua, ayat kedua ni apa benda? Dia just a pointless sentence to make you confused. Okay, so let's look at question A. Determine the equation of motions describing the dynamics of the system. Okay, soalan A ni dia suruh buat equation of motions. Okay, so meaning that you need to draw free body diagram and everything lah. So some students, they think equation of motions, no need to draw free body diagram. So they actually lose marks, okay? Maybe half of the marks. So when question state equation of motions, maksudnya constitute sekali free body diagram. You need to draw free body diagram and show the direction of forces. Then after that, you write the equation of motions, maybe in matrix form, okay? Okay, so let's look at this figure one by one. So there are two mass. We have M1 and M2. Okay, so okay, macam confusing sikit. So let's look at M2 first, okay? Sebab dia paling atas. Okay, so let's draw M2. Okay, so the direction of M2 is upward. Okay, so let's look at the components that are connected with M2. So we have spring K2 here. So spring K2 is connected with M2. So we have a force from the spring that try to resist motion Y2. So we have K2, Y2 acting downward. And then on M2, we have this B2 here. So B2 is something like friction of the mass M, of the mass M2 with this massless frame. Okay, so M2 ni terletak dalam satu frame, let's say frame kaca. Then dia ada friction between M2 and that frame kaca, okay? That massless frame. Tapi that frame tak ada mass, okay? So there's a friction B2 between M2 and this frame. If you look at this frame, when M1 moves, bila M1 bergerak, this frame will bergerak as well, okay? So this frame is not static, dia bukan tak bergerak. Dia bergerak bila M1 bergerak. So maksudnya B2 tadi dia connected dengan massless frame, but this massless frame is actually connected with M1. So you can imagine B2 as a friction between M2 and M1, okay? So bila M1 gerak, ada friction with M2 due to the massless frame. Okay, so B2 is friction, so it will act downward, B2, Y2 dot. And don't forget the inertia, M2, Y2 double dot. Okay, let's find the upward forces. So first the spring K2 is also connected with M1. So we have an upward force K2, Y1. And then the friction just now, okay? So the friction just now is friction between M2 and the massless frame that is directly connected with M1. So when M1 moves, ada friction dengan M2. So we have B2, Y1 dot. Ada kelas? Okay, faham? Okay, tak apa. Tengah semayang kot. Okay, so now let's look at M1, Y1 upward. Okay, so on M1 we have 3 springs connected. So we have spring K2 and spring K1 half and also spring K1 half connected with the input displacement or the displacement of the road surface. Okay, kalau remember last week kita ada belajar pasal road surface. And we have B2, friction M2 and M1. And we have B1 here, damper between M1 and the road surface. Okay, banyak sangat. Let's do spring first, okay? So first spring is K2, Y1. And then we have K2, Y2 due to connection with M2. And then we have spring. So K1 half ada 2. So K1 je lah. So here we have K1, Y1. And the spring K1 half, both of them are connected with Y0. So last week kita belajar kalau ada road surface, kita treat it as forces, okay? A force from input force, okay? An input force. But it's connected with spring, so dia punya force is something like displacement type of force, okay? So we have upward force, K1, Y0. And then we have damper B1. So damper B1, Y1 dot. And the damper B1 also connected with Y0. Okay, so treat this similar with K1. So we have B1, Y0 dot. Okay. And lastly, we have this friction just now. Okay. So friction B2, Y1 dot. And the friction also with M2. So we have B2, Y2 dot. And don't forget the inertia M1. So we have M1 here. M1, Y1, double dot. Okay, so these are all the forces on the dynamic absorbers. Then you can write the equation of motion and find the transfer function. Okay, so make sure the free body diagram is correct and has all the forces related, okay, or connected to the system. Okay, any question before we end this lecture? Okay, so tak ada soalan? Okay, so I hope you guys can try do this tutorial, try to understand it. Gravity tak payah. So gravity, usually we exclude gravity. Ada tutorial semua ada dekat YouTube. Okay, so usually for vertical motion, kita exclude gravity. There's a reason. Actually, ada dalam buku mana tahu ada derive lah kenapa gravity tak exclude. Ada reasons there lah. Yeah, I forgot which book. But it's like the gravity is somehow cancel, macam cancel lah. Okay. But unless the question said consider gravity as well, contohnya macam tu. So you include gravity. But most of the time we don't include gravity. I think it's because of this is vibration type motion. So we exclude gravity. Okay, so all the videos are uploaded in YouTube. So boleh buka link YouTube videos, previous videos, and you just search the playlist. Okay. You just click on the YouTube link that I gave in WhatsApp group. Okay. And then from there you can subscribe to my channel. I also forgot my channel name. X Gaming, gue lupa dah benda lah. Don't forget to subscribe and leave a thumbs up. Gitu. Okay. Any question you can ask me through WhatsApp, or you can ask me bila-bila. Okay. Jangan buat tu tidur lah. Okay, so that's it for our today's class. So tomorrow we will learn modeling of dynamic system as well, but for rotational system with gears as well. So I hope you understand the concept, how to find the forces based on the connections of the components. Because in Wednesday lecture, it involves the same thing, but the motion is rotation, okay, instead of translation. Okay, so I hope you understand and try to understand if you don't get it during this class. Okay, try to watch the YouTube video later. Okay, so that's it for today. Thank you for your time, and Assalamualaikum and good afternoon.
Thank you, Doctor.